what is microcontroller and how does it works. Basically, you can think about microcontroller seems you think about very underpowered personal computer because they both have a very similar structure. Only in case of the personal computer, you have the part like CPU memories and the serial interface is separate, where in case of microcontroller, they are integrated in one chip. Same as you can connect a keyboard and a monitor to a personal computer to input and output some informations, you can do it also with microcontroller only in that case using for example buttons and LED light. But what exactly is a microcontroller and how it is made to fully understand that you have some basic knowledge about elements that are used in electronics like resistors, transistors and diodes. Here will be a brief recap. Resistors. Resistor is used to limit the current that is flowing through the circuit or to create a voltage drop about transistors. You can think that is flowing through the circuit or to create a voltage drop about transistor. In case of volt to control the flow, you are turning the handle. But in the case of transistor to control the current through the transistor, you are changing the base current and the diode is simply an element that allows to flow the current in one direction but it blocks the current in case if it's want to flow in the other direction. Using this basic element, we can create something called logic gate, and this is very important because this is the link that allows us to go from analog electronics to digital electronics. Here, for example, you can see a logic and gate that is made from 2 transistors and 3 resistors. Suppose that we have connected plus 5 volts to the collector of transistor T1. If there will be 0 volt on input A and input B there will be 0, also show an output 0 volt. If we will apply plus 5 volt on input A and 0 volt on input B, so output also will get the 0 volt. If we will apply the 5 volt on the input A and input B is the 0 volt, output will get the 0. And if we will apply the 5 volt on the input A and 5 volt on the input B, so you will get the output also 5 volt. Because both of these transistors are in open state, well, changing this voltage level 1 also filled out this table with the corresponding voltages for both inputs and output. Now replacing the 0 volt with zeros and plus 5 volts with ones, we get something that is called the truth table. And this is where digital electronics start. In digital electronics, there are only high and low logic levels, and those are those zeros and ones that you can see in this table. Is that we can describe this truth table using an equation, and in this case we can use an equation input A is multiplied by input B equals the output. In digital electronics, there are multiple logic gates and each gate has its own truth table and its own equation. I have to say that mathematics used in digital electronics is different from regular mathematics and it is called the Boolean algebra. What Boolean algebra allows us to do is to describe digital circuits using mathematical equations, and it is very useful in describing complex digital circuits and simplifying them. Now using these logic gates, we can create more complex structures that is capable for adding, subtraction, multiplications and even storing digital informations. These are the type of structure that are inside microcontroller, and it is possible to control them by using something called program. Program is stored inside microcontroller's internal memory, and it can be transferred into microcontroller through programming pins that are specially made for this purpose. You can think about program same as you would think about lines of zeros and ones. Lines of zeros and ones. Each line of the program has predefined length and each part of the line has its own meaning. Now let's go through one example. This won't be an actual program, but it should serve as a good example to better understand how the program is read by the microcontroller. Because lines of the code are always read in a certain sequence by the microcontroller. We will go through the program starting from line 1. Line 1 allowed by line 2 and followed by line 3. First, let's split all blinds in 3 parts. This first part of the first line will be a write operation. So it means that we will write some information in somewhere. The second part of the line will tell us where will we write the informations, and in this case we will write it in the register. Register 1. If you are wondering that what is register? Register is simply a memory cell that is capable of storing some information. And now we come to the third part of this first line, and it tells us what kind of information we want to write in register 1. And in this case we want to write number 4. If you would convert 0101 from binary to decimal numbers, that it would be number 4. So if we go one more time over this first line of code, and what is said to the microcontroller, it says write in register 1 number 4, and so we come to the second line of code, and in this case again it will start with the write operation. The second part of the code will tell us in which registers we to write these informations. In this case we want to read these informations in register 2, and the third part of the code will again tell us what kind of information, what kind of number we want stored in register 2, and it will be, in this case it will be number 6. If we would convert 0110 from binary to decimal, it would be number 6. The third line of code will start with a different operation. In this case it will be an add operations, and we will add the number that is not in register 1 2, the number that is in the register 2, and the result will be stored in register 2. So what we get as result after executing these 3 lines of code, we get the sum of number 4 and number 6 in second register, and that would be number 10. If we would convert 1010 from binary to decimal numbers, then it would be number 10. Now what we could do, if we would want to example, we could display the result using LED lights that are connected to the microcontroller. Of course, as I said before, this is not an actual program, but this is approximate example of these lines of code are executed by a microcontroller. Now let's remove these binary codes and leave only those written words. What we get here is something similar to assembly language. What is in assembly language? It is a very low level programming language. As you can imagine, it would be very difficult for a human to memorize what each strings of the zeros and ones means. To make the job of programming easier, people have replaced these zeros and ones with written words number that are a lot of more meaningful for a human. Therefore, it becomes a lot simpler to write a program when the program in assembly language is finished and we want to burn it in microcontroller. We are using something called as blur that can note our assembly code into zeros and ones that can be understood by the microcontroller. Here will be an example of an actual assembly code. Although it is a lot easier to read program using this kind of language instead of zeros and ones, it is still very difficult to write large and complex programs, and you also have to understand very well how the microcontrollers is built and how it works. This is why there are a lot of other higher level programming languages that specify the job of programming. Even more, some examples would be programming languages like C and C++. The main benefits of these languages are that they are easier to understand and they greatly reduce the time needed to create a program. Because, for example, what can be done in assembly language using 5 or 10 lines of code, it can be reduced to maybe only 1 line of code in this higher level programming language. One more thing is that they are more abstract, and that means that you don't have to understand hardware as well as to be able to create a program, and the number of applications where microcontroller can be used is endless and is greatly depend on your imaginations. For example, you can take microcontroller, add some buttons and some LCD screens and create a digital clock. Microcontrollers are used in everything starting from children's toys and ending with that the refrigerator that stand in your kitchen. Now you should have a better understanding what is microcontroller, how it works and where it can be used.